welcome to the maths place, another maths class. Today we'll be talking about sorts. What are sorts? Sorts are numbers that have square roots on them. Square root of 25, square root of 45, square root of 99. These are sorts. Sometimes they are additions of sorts. 99, square root of 99 plus square root of of 15, something like this. Sometimes you have multiplication of sorts, square root of 25 times square root of 16. So today we'll be looking at how to simplify sorts, addition of sorts, multiplication of sorts, and the like. We are welcome. Let's look at some examples of sorts, and now we can express them. There are roots governing sorts. If you have something like root mn, it's the same thing as root m times root n. This is the multiplication rule. Then we have the division rule. Have something like this, root m over n. It will give us root m divided by root n. These are rules governing sorts. Now, if you are to simplify sorts, what are we supposed to do? For instance, we are to simplify a sort like this, 45. What are we supposed to do? To simplify sorts, we have to divide the number under the root by 2 factors, and then at least one of the factor must be a perfect square. For instance, this is the same thing as 9 times root 45 is the same thing as root 9 times 45. That's 9 times 5. We have a square root of it. Now, to simplify sorts of any given number, we must ensure that one of the 2 factors, one of the products of the 2 factors must be a perfect square. What are perfect square? Perfect square are things like numbers like 9, 4, 9, 16, 25, 49, 81, 64, 144, 100, 121, 121. What are perfect square? Perfect squares are numbers that when you find a square root, it gives us, they give us numbers without decimal. When we find a square root, they give us an integer without decimal. For instance, if we find the square root of 4, it gives us 2. The square root of 9 gives us 3. The square root of 25 gives us 5. The square root of 16 gives us 4. The square root of 49 gives us 7. 7 times 7, 49. 4 times 4, 16. 2 times 2, 4. And 3 times 3, 9. So these are all perfect squares. Because when we find a square root, we have an integer, we have a number without decimal. The square root of 81 is 9. The square root of 64 is 8. The square root of 144 is 12. The square root of 100 is 10. The square root of 121 is 11. So these are perfect squares are numbers that when we find their square root, it gives us another integer without a decimal. So the rule by sorts, we divide the number into at least a factor of 2 products, at least one of which must be a perfect square. So it's something like this. We have what is the square root of 9? That's 3. Then we leave this way. Let's look at another question. What's the square root of this? The square root of 162. The rule says that to simplify sorts, we must divide the number under the square root by at least 2 products in which one of the factors is a perfect square. So this is 81 times 2. The square root of 162 is square root of 81 times 2. 81 times 2 is 162. So the square root of 89 of 81 is 9, and then we have this. Let's look at another question. If you have something like this, is the same thing as saying square root of this times this. The square root of x squared will be x, then we have y. Let's look at some further examples. If you have 3 root 50, 3 root 50, we'll find we divide 50 into at least 2 factors in which one of the factors of the number must be a perfect square. That's 3 over root 25 times 2. This is a perfect square. The square root will be 5. So this is 3 times 5 root 2. That gives us 15 root 2. Another question. To simplify the following. Simplify the following. We have root 99. Root 99 is what? 9 times 11 is 99. To simplify any sort, we must divide the number under consideration into at least 2 factors, a product of 2 factors, one of which one must be a perfect square. The square root of 9 is 3, and then so we have this. Another question, square root of 20. Square root of 20 here, this gives us square root of 5 times 4. We could have well said 2 times 10, but none of this is a perfect square. So we jettison this and we come this way. 5 times 4. 4 is a perfect square. The square root of 4 is 2. And then we have root 5. We leave the root 5 there. Another question. Root 75. To simplify root 75, we divide this number into at least 2 factors, one of which must be a perfect square. That will be 25 times 3 will give us 75. So what is the square root of 25? 5 root 3. These are examples of how to simplify. So we consider some more. We simplify 63. 63 is the same thing as 9 times 7. Then we look for the square root. What is the square root of 9? 3. 7. Another question. Square root of 84. Square root of 84, we have something like 7 times 12. But none of this is a perfect square. So we simplify further. We say 12 is the same as 4 times 3. 4 is a perfect square. So it's the same as saying 3 times 7, 21, and then we leave the 4. And that will give us square root of 4 is 2, and then we leave the 21 there. So sometimes we are given numbers that we can't come up immediately with a particular perfect square under it. So we simplify it further. Once we get the perfect square, we isolate the perfect square and we multiply the remaining one and find the square root. So this will be 3 times 7 times 3, 21. Then we leave the 4. We find the square root of 4 and we leave the root 2 root 5. Root 98. Root 98 is the same thing as saying 7 times 14. Now none of this is a perfect square. So we simplify further. 7 times 14 is 2 times 7. So which is a perfect square? None of these actually. But 7 times 7 is 49. 49 is a perfect square. So we come this way. 49 times 2 will give us 98. So what's The square root of 49 is 7. We have 7 root 2. As simple as this. Sometimes you are asked to simplify the square root into a single number. For instance, we have 2 root 5 and we have to simplify into a single number. What do? We just say 2 times 2 times 5. 2 times 2 is 4. 4 times 2 times 2 is 4. 4 times 5 is 20. So 2 root 5 is same as root 20. If we simplify this further, we get this. Another question is, if we're given something like simplify the square root into a single number, we have 7 root 3. How do we do this? To get into a single number, we just say this 7 has been, they found the square root of a particular number to give us 7. So what we do is that we expand the 7. 7 times 7 times 3. We can say 27 times 21. That will give us 7 times 1, 7, 7 times 2. So we have something like this. Or say 49 times 3. It gives us, this is what we have. Another question, 2 root 3. 2 root 3. What do we have here? We say 2 times 2 times 3 equals 2 times 2 is 4. 4 times 3. That's root 12. If we simplify root 12, we have 2 root 3. Let's try and simplify root 12. 12 is same thing as root 4 times 3. That's the square root of 4 is 2. And then we'll bring the 3. The same thing as what we had earlier. Let's look at another question. 3 root 3. Simplify this square root into a single number. What do we have? This will be 3 times 3. Then times what is in the under the root? 3 times 3, 9. 9 times 3 is 27. So 3 root 3 is same thing as. So if we are given a surd and then we are asked to simplify it into a single number, what we do is that the number outside the surd will multiply by itself, and then we put the number within the surd singly the way it is, and then we multiply that way. Another question, root 4, 6, something like this. So it will be 4 times 4 times 6. 4 times 4 is 16. 16 times 6. 6 times 6, 36. 6 remainder 3 is 96. Root 96. So 4 root 6 is the same thing as root 96. We can go on and on solving various questions. Another question, 5 root 2 into a single number to be 5 times 5. A number outside the root by itself, then within the root just once. 5 times 5 is 25 times 2. That's 50. 50. This is what it gives us. Yet another question. Yet another question. 10 root 3. We are asked to get Whereas to simplify it into a single number, that will be 10 times 10 times 3. 10 times 10 is 100, 100 times 3 is 300. So 300. If you want to know whether root 300 is the same as this, what we do is root 300 is the same thing as 100 times 3. Root 100 times 3. What's the square root of 100? 10. And then root 3. This is the same thing as what we have here. Yet another question. 5 root 7 to a single number. That will be 5 times 5 times 7. Then the square root. 5 times 5 is 25 times 7. What does this give us? 5 times 5 is 35. That's 5, remainder 3. 5 times 2 is 14. Plus 3, 15, 16, 17. So, this is what we have. Root 175 is the same thing as 5 root 7. Let's look at another question. 3 root 8. We have to simplify this into a single number. That will be 3 times 3 times 8. That will be 9 times 8. That will be root 72. So with these examples, I want to believe that you are getting familiarized with sorts, how to simplify sorts into smaller units. In our next class, we'll be going into addition and subtraction of sort. Thank you. Meet you in the next class. Addition and subtraction of sorts.